Let's go ahead and do some practice problems where we're calculating frequency, wavelength, or energy. And so what we're going to do is we're going to use these equations here. So we have these two equations that we're going to use, and we're going to use those to calculate one of these three variables. Now notice how this first equation here is C equals V lambda. Lambda is upside down Y, so this right here is lambda. Now notice how we have V, which is frequency, and lambda, which is wavelength. And so the frequency, the units for frequency, this is per second. This is 1/2 or hertz. They're the same units, so just keep that in mind. But it's either the frequency is either going to have the units of hertz or 1/2. Notice how lambda, the units for lambda is meters, so the units for wavelength is meters, and the units for energy is joules. Now I'm going to go ahead and tell you, you have to be really, really careful with your units, because sometimes a problem will not give you meters. It'll give you nanometers, or it'll give you centimeters, or give you some other meter. But if it gives you something like nanometers or micrometers, you have to convert it to meters. So be very careful. The other thing too is you will have problems that will ask you to answer the question in not joules but kilojoules. And so just know that these equations will give us the energy in joules, and we'll have to convert it to kilojoules if the problem is asking that. So let's go ahead and talk about these constants as well. And so you'll see that we have C right here, and C happens to be the speed of light, which is 3 times 10 to the 8. And we have H, which H is 6.626 times 10 to the negative 34. Let's go ahead and choose a different color for that. Now, what I will say is these are constants. That means we always have these numbers. The other thing, too, is when considering sig figs, you do not consider the constant, the sig figs of the constants when you are considering sig figs. So they do not influence the sig figs of the sig figs of the answer that you'll get. So let's go ahead and do a practice problem here. What is the wavelength? All right, so it's asking for wavelength in meters of a photon of light that has a frequency of that. And so it's asking for wavelength, and it's giving us frequency. And so let's go ahead and take a look at these equations here. So we have two equations. We have this equation and this equation. Which equation has both wavelength and frequency? Well, this one right here has our frequency, but it does not have wavelength. However, this one has both of them. So that happens to be the equation that we're going to use to solve this problem. And so we're going to use C equals lambda V. And so that's the equation we're going to use. And it's actually really simple. All you need to do is plug in your equation, plug in the numbers to your equation, and then solve for the unknown that you're looking for. So let's go ahead and plug in those numbers. Well, what is C? The problem doesn't give us C. But if you were to look over here, we will always have C. C is 3 times 10 to the 8. So we know that C is 3 times 10 to the 8. Now what about lambda? We don't have lambda, but we do have frequency. And so I'm going to go ahead and just write the frequency here. I'm going to put it in parentheses. It's 2.10 times 10 to the 14. And that is our setup there. Now at this point, the only thing we need to do is use algebra to solve for lambda. And the way you do that is notice how these two are multiplying each other. So what you need to do is you need to divide by 2.1 times 10 to the 14. But whatever you do to one side, you have to do to the other as well. When you do that, these cancel out, kind of like moles, and we're left with lambda. And so we're left with this setup here where lambda which is wavelength, is equal to 3 times 10 to the 8 divided by 2.1 times 10 to the 14. So let's go and plug that in our calculator. And what you end up getting is lambda is equal to 1.43 times 10 to the negative 6. Now the other thing we need to do is we need to make sure that we write our units. The units for wavelength, if you take a look, they are meters. And the problem is asking for us to do it in meters, so that's great. So it's meters. And then we box our answer. Now, what I'll say is, notice how we end with 3 sig figs, and the reason why we end with 3 sig figs is because look at what we're starting with. We're starting with 3 sig figs. All right, let's go ahead and go to the next one now. When sodium is heated, a yellow spectral line whose energy is this many joules per photon is produced. What is the frequency? So in this situation, it's giving us energy, and it's asking for frequency. And so let's go ahead and take a look at our equations here. Which of our equations deals with energy and frequency? Well, it's this one. That one deals with energy and frequency. And so let's go ahead and use that equation there. So we're going to use E equals HV. So let's go ahead and start plugging in our numbers here. So we have energy. It's 3.37 times 10 to the negative 19. And again, one thing I want to point out is that these equations here, they are giving you the energy of a single photon. That's actually something important to keep in mind, that these equations are for a single photon, but later on we'll talk about a mole of photons. All right, equals H. Well, the problem doesn't give us H. However, H is a constant. H will always be 6.626 times 10 to the negative 34. So we have 6.626 times 10 to the negative 34. And then multiply it by V, which we don't have. And now all we need to do is solve for V using algebra. And it's just like before. We're going to end up dividing by 6.626 times 10 to the negative 34 on this side, because this will cancel it out, giving us V by itself. But whatever you do to one side, you have to do to the other side as well. And so that's what we end up with. And so we end up with frequency is equal to those numbers dividing each other. All right, so let's go ahead and type that in the calculator. All right, and then what we end up with is 5.08 times 10 to the 14. Now notice how we're ending with 3 sig figs, because we're starting with 3 sig figs. And then also we need to put our units. But what are the units for frequency? Well, there's 2 units. We either have per second, which is 1 over second, or hertz. I personally like to write per second, but you can totally write hertz if you want. Now let's go ahead and talk about number 3 here, all right? But to talk about number 3, I'm going to go ahead and skip to number 5, because I think if we did number 5, it would help us with number 3. Number 5 says to derive an equation expressing E in terms of H, C, and lambda. And so what that means is we need to derive an equation that has these 3 variables in there, or the 2 constants in the variable, to help us calculate energy. So in other words, we need to come up with an equation to where we can solve for energy for a given wavelength. Well, energy is equal to H times V, and we know that the speed of light is equal to lambda V. And so what we can do is we can actually, in the second equation, we can solve for V. And when we solve for V, we do it by dividing by lambda here. And we will end up with this situation here. So all I did was I took that equation there and solved for the frequency. Well, if the frequency equals this, then all we need to do is plug this into there, and we can actually derive an equation where we can have energy being calculated using the wavelength, which ends up being h c over lambda. And so this equation here is actually a third equation that we can use to solve for energy if we're given wavelength. And so this here, and I'm going to let you know that this equation is actually on your equation sheet, which you will be able to use on the exam. So you can look on your equation sheet there. It's in the front of your booklet. And so energy is equal to hc over lambda. And so all we need to do is plug in these numbers here. Now, one thing I will say is you'll actually commonly see it written like this. It's the same exact thing. So let's go ahead and figure out E here with this equation. So we don't know what E is. However, we do know what H is. It's a constant, which is 6.626 times 10 to the negative 34. We know what C is because that's a constant as well. That's 3 times 10 to the 8. And then what we do is we divide it by the wavelength, which is 8.27 times 10 to the negative 7. Now all we need to do is plug that into our calculator to get the right answer. And what we end up with when we type this in the calculator is E is equal to 2.40 times 10 to the negative 19. And this is going to be, this answer, we're going to answer this in joules because the unit for energy is joules. And notice how there's 3 sig figs here because we started with 3 sig figs. Now let's go ahead and box our answer as well. And we forgot to box this one. All right. So here are, this is the, so this is using each of the equations here. So you see there's 3 total equations that we've used in this situation, in these 3 problems. And so you'll see those are the 3 equations. You will have those equations on the exam. You don't need to memorize them. You don't need to memorize the constants either. But let's go ahead and move on to the next problem here. This next problem is you will have a problem like this on the exam, and it's going to be very important that you understand how to do particularly this last part here. So let's go ahead and get started. So a certain green light has a frequency, okay, so we're given frequency of 6.26 times 10 to the 14, and it's asking for wavelength. Well, we're going to use this equation here to solve for the wavelength. And what we end up with is this equation with the numbers in there, and so all we have to do is solve for wavelength. And we end up with this situation here, where we have lambda is equal to 3 times 10 to the 8 divided by 6.626 times 10 to the 14. So let's plug that in our calculator. And that's our answer. All right, let's go ahead and look at letter B here. So what is the energy of 1 photon? So it's asking for the energy of 1 photon. And again, the equation that we have for energy solves for that the energy of 1 photon. Now there's actually 2 ways we can do this. We can either use this new equation here because we have our wavelength, or we can use this equation, which is E equals HV, because we have the frequency as well. So let's go ahead and I'm going to use that one that I wrote on the board there. And when we plug in our numbers, that's the equation that we get, that's the setup that we get. So let's go ahead and plug it into the calculator. So what we end up with now is energy is equal to 4.15 times 10 to the negative 19. So let's go ahead and talk about letter C. Like I said, you will have a question like this on the exam, and this is where you really need to pay attention to the units that it's asking for. And so, first off, it says answer in joules. That's not what it wants. It says right here, what is it in kilojoules per mole? So what it's wanting to know is what is the energy of 1 mole of photons? What is the energy of 1 mole of photons in kilojoule per mole? Well, let's go ahead and think about this. Well, what is the energy of one photon? Well, we just calculated that. So 1 photon is equal to 4.15 times 10 to the negative 19 joules. That's the energy of 1 photon. Well, how many photons is 1 mole? Well, we know that 1 mole is going to be 6.02 times 10 to the 23rd photons. And so this right here is the energy of 1 photon. But what if we had this many photons? What energy would we have? The only thing we need to do is multiply those numbers. And to give you an example, what if we had 2 photons? Well, we would have double the energy. What if we had 3 photons? We would have triple the energy. What if we had 10 photons? We would have 10 times the energy of 1 photon. What if we had 6.02 times 10 to the 23rd photons? Well, that's how many times more energy we would have. And so all you need to do is multiply this by 6.02 times 10 to the 23rd. And what you end up with, is 249,830 joules per mole. So if we had 1 mole of photons, we would end up with that many joules. So that's how many joules are in 1 mole. However, it's not asking for joules, it's asking for it in kilojoules. And so now we need to convert it to kilojoules. And so all we gotta do is take this 249,830 joules per mole. And we're gonna put joules on the bottom, we're gonna put kilojoules on top. We know that 1 kilojoule is 10 to the 3 joules using the metric system. And with sig figs, because we started with 3 sig figs, we should end with 3 sig figs, and we will end up with 250 kilojoules per mole. And that is the answer. So let's go ahead and recap real quick. In part B, we figured out how many joules are in how many joules of energy are in 1 photon. So 1 photon has that many joules of energy. In part C, it's asking, well, how much energy is in a mole of photons? Well, a mole is 6.02 times 10 to the 23rd, and so what you do is you multiply the amount of energy in 1 photon by Avogadro's number to give you the amount of energy in a mole of photons, and then you take the joules and convert it to kilojoules. And I know that's a long process. You do have a practice problem on it in your independent practice. Go ahead and give that one a shot and check the key to make sure that you have the right answer. And if you have any questions on any of this, feel free to email me or ask me in class, and you have a great day.